So welcome to the another video lecture on load word, store word. So in the previous lecture, I have discussed about how to build a data path, and I have discussed about the control unit and the functional unit for data path for the ALU instructions, that is R type instruction. So now let us discuss about the load word. So first one is what is load word means. I'm going to store the data from the offset T2 to T1. This is my destination. Okay, so this is RT and this is my RS. Okay, for the first step is the instruction is fetched from the instruction memory. So this is my instruction fetch stage. So the program counter points the 4000 address at the from the read address. The instruction that is this one is load word. This instruction will be get fetched. Okay, so you can see this is the instruction is 32 bits, so it is 31 to 26 it represent. If you see the instruction, it is this is my load, and 21 to 26 represent with this load word. Okay, and RS represent the source value and RT represent the destination. So 21 to 25 represent the source value. So it is nothing but T2. So this is my T2 and this is my T1. Okay. So in this address, the data from the T2 get fetched. Okay. So this is my data from the T2, and you can see what is offset. The offset is 0 to 15. It represents some address. So what it represents is it is nothing but offset plus T2. So this is my base address, and you have to add the offset value. Okay, so the offset value is from 0 to 50. Okay, and it is a 16-bit value, right? So now I'm going to I'm discussing the instruction decoding stage. So using the sign extension, it would convert it into a 32-bit, and it is given to a marks. Okay. So since the AL SRC is 1, the offset get added with the T2, so I'm getting the output. Okay, which is nothing but an address. Okay, so I'm going to what I'm going to do. So I'm going to the data from this address should be read. So it has to be read. So memory read must be 1 and memory write must be 0. So this memory to register must be equal to 1. Then only it has to go to here, and it will be stored in this write data. Okay. So the write data must be stored in this write register. So the write register value must be selected. What is the write register value? Write register value must be T1, address of the T1. So this has to be 0. Okay, so the register destination must be equal to 0. So since I am performing a register write, it has to be 1 register write. So this stage is instruction decoding, and this one is instruction execution, and this one is memory write, and this one is write back. So totally I have 5 stages. Okay, so once it get completed, so I'm not going to use any ALU up, right? So since I am performing only addition, so the ALU control must be equal to so for addition it will be a 4-bit code. So for that part. So after that the PC has to fetch the next instruction, right? So 4000 plus 4 is 4004. So the max PC SRC must be equal to 0. Okay, so it will go here. Okay, so it will fetch the next instruction as 4004. Okay, because this is how this load word will work. Next, let me discuss about the store word. Store word. So again, it will be located in the 4000 address. So at the address, the instruction get fetched, and the instruction 30, 31 to 26 represent it is a store word. So it is given to a control unit, and here the 21 to 25. This is my so it will be stored like this, right? The store word is now this is my RT and this is my RS. Okay, so RT, RT is 16 to 20. 16 to 20. This is T1 and this is T2. Okay, T2 and the data from the T2 is here. So I'm going to take the offset, right? So this is my offset, and it comes to here, right? The offset value. So this has to be selected to 1. So the offset and T2 get added, right? Offset and T2 get added. So now from, so this is my T2 and this is my T1, right? So it has to go to the read register 2. It has to go to the read register 2. From the read register 2, from the data from the T1 is directly going to the write data. Okay, write data. So I'm going to write the data in this address. Okay, in this address T2 plus offset. So the writes memory write must be equal to 1 and memory read equal to 0. So there won't be any stage. So after that this must be X. This mux also I'm not going to use, and I don't require the register write also, right? So it has to be 0, and I don't want to use the ALU opt also. Okay, so so after that what will do? So this will go to the adder. The current address 4000. It will add with 4, so it will be 4004. After that this has to be 0. So when it will be 1 means whenever the branch instruction and jump instruction executed means it will be 1. Okay, so after that it will go to here, and now I'll get 4004. So the PC will point the 4004. So this is how the stored word will work.